Lesson 8.3, defining and using zero and negative exponents. For the last two lessons, we've been discussing properties of exponents, dealing with multiplication and division. So today's lesson, we're going to talk about zero and negative exponents. Okay, just to introduce this lesson off the bat, let's go over some important things that you need to know. You need to know that any number to the zero power is always going to be 1. So, a to the zero power, you know, is going to equal 1. But a cannot be 0. Okay, this number right here, it cannot be 0. So if I take 5 to the zero power, that's always going to equal 1. And you know, you can always plug it into a calculator and try any number you want to. Take it to the zero power, you're going to get 1. Our next definition is dealing with a negative exponent. If I have a to the negative n, and I take the reciprocal of that, okay, I have a to the negative n, and I take the reciprocal. Now remember, a reciprocal just means you're going to flip it. If I have a to the negative n over 1, and I take the reciprocal of that, that's going to become 1 over a to the positive n. Okay? When you take the reciprocal of a negative number, it changes to a positive. And you want to keep that in mind when we're dealing with negative exponents. Same thing, if I start off with a to the positive n, and I ask you for the reciprocal of that, you're going to flip it, and it's going to become 1 over a to the negative n. Again, you can see that we flipped this, so it changed the sign of the exponent. So going back over here to your definitions, if I have a to the negative n and I want the reciprocal, again, you know that's going to become 1 over a to the positive n. Again, a cannot be 0. So let's look at 2 to the negative first power. You know, any number is always over 1. So if I ask you to find the reciprocal, you're going to flip it. That's going to become 2 to the positive first power. Same thing here. If I have a to the positive n, the reciprocal of that is going to be 1 over a to the negative n. Again, a cannot equal 0. So let's look at 2. What is the reciprocal of 2? Well, you know there's an imaginary exponent of 1 with any whole number. Okay? So if I flip this, it's going to become 1 over 2 to the negative 1. Alright. So now that you know the basic definitions of zero exponents and negative exponents, let's practice using those in these different examples. Example 1, it says evaluate the expression. I have 2 to the negative third power. The whole key here is that we don't want negative exponents. We want to get rid of those. So to get rid of a negative exponent, you have to take the reciprocal. So this is going to become 1 over 2 to the third power. And you want to evaluate from there. So we're going to have 1 over, what is 2 cubed? 2 times 2 times 2 is 8. So it is now simplified. I'm not so much worried about following our steps here. Look at B. I have negative 10 to the 0 power. Remember, any number to the 0 power is always 1. C. Here I have a power of a quotient. When you have a power of a quotient, remember you have to distribute this power to the numerator and to the denominator. So that's going to become 1 to the negative cube divided by 4 to the negative cube. want to get rid of these negative exponents, so I need to flip it. I need to take the reciprocal. So that's going to become 4 cubed over 1 cubed. Simplify from there. What is 4 cubed? We know it's going to be 64. 1 cubed is 1. 64 over 1 is just 64. It's just the same step every time. You just got to follow different steps. 0 to the negative 7 power. Remember, this base cannot be 0, so we know this isn't going to work, but let me show you why it won't work. I can see a negative exponent, and I'm going to put it over 1, and I'm going to take the reciprocal to get rid of this negative exponent, so we're going to have 1 over 0 to the 7th power. Well, if I break that on down, that's going to become 1 divided by 0 to the 7th power is just 0. You know that you cannot divide any number by 0. 0 can never be your bottom number. Therefore, it's going to be undefined. So, 0 to the negative 7 is undefined. Alright, let's review our different properties from the last 2 lessons. Alright, first property that we were introduced to. I can see I have multiplication, and I can see I have like bases. When you multiply like bases, remember we're going to add the exponents. So that's going to become a to the m plus n. That is our product of powers property. Alright, our second property, I can see that I have a power of a power. When you have a power of a power, remember you multiply the exponents, so that's going to become a to the m times n. Power of a power. Okay. Our third property, I can see I have a power of a product. It's a product because this is multiplication. You have to distribute this exponent to each factor. So that's going to become a to the m times b to the m. Power of a product. And that was from lesson 8.1. That's a review. Now going into lesson 8.2 when we were dealing with quotients. Here I can see I'm dividing like bases, so what do I do with their exponents? I subtract. So that's going to become a to the m minus n. Quotient of powers is what that one was called. Quotient of powers. And our last property with division, I can see I have a power of a quotient. I have to distribute this exponent to the numerator and to the denominator. So I'm going to have a to the m divided by b to the m. Again, that was the power of a quotient. That was a review from lessons 8.1 and 8.2. Alright, let's practice on this. Review everything we know. I can see I'm multiplying like bases. If you're multiplying like bases, we add the exponents. So I'm going to have negative 5 to the 4 plus negative 4. Simplify there, you're going to have negative 5 to the 4 plus negative 4 gives you 0. Anything to the 0 power is going to be 1. Power of a power. Power of a power, remember I multiply exponents. So I'm going to have 5 to the negative 2 times negative 2, which gives me 5 to the, a negative times a negative is positive, so 5 to the 4th. And 5 to the 4th power is going to give me 625. C. say I have a negative exponent, how am I going to make it positive? Remember, I have to flip it. I have to take the reciprocal. So that's going to become 1 over, oops, that's going to become 4 squared over 1. Sorry. I went blank there for a minute. What is 4 squared? Well, we know it's 16. Alright, let's look at D. Here I can see I'm dividing like bases, so I'm going to have 3. When you divide like bases, what do you do with their exponents? You subtract. So that's going to be 2 minus negative 1, which gives me, what's a negative negative? A plus plus. So I'm going to have 3 cubed. 3 cubed gives me 27. Alright, moving right along. I'll do a couple of checkpoints with y'all to make sure you're understanding. Get number 1. I'm going to distribute this exponent, so I'm going to have 1 to the negative 1 divided by 8 to the negative 1. I don't want negative exponents, so if I flip them, that's going to become 8 to the first over 1 to the first, which is going to break down to be just 8. Alright, look at number 4. Power of a power, I know I multiply exponents, so I'm going to have 5 to the negative 2. I don't want a negative exponent, so if I flip that, it's going to become 1 over 5 squared, which gives me 1 over 25. Alright, in our last example of this lesson, I'm going to rewrite it over here because y'all already know by now. Y'all know I don't like following the book's notes. I do it my own way. I'm going to rewrite the problem over here. That way we have more room. Y'all also know that I require lots of room when I'm working algebra. And that's because I don't like all my work to be crammed together. It's easier for me to see my work if I spread it out. Okay, let's look at the numerator. So far in the numerator, I have 2 times w to the negative third times x. Denominator, I have a power that I have to distribute to each factor. So I'm going to have 2 squared times w squared times x squared. Simplify from there, I'm going to have 2 over 4 w to the negative 3 times x, and the numerator is going to stay the same. Okay, I'm going to simplify from here. Remember, I'm taking it step by step by step. Is 2 over 4 reduced? No, that reduces to 1/2. Okay, I mark them out as I simplify. Dividing like bases, I subtract exponents. So negative 3 minus 2 is going to give me w to the negative 5th. And then this x has an imaginary 1, so 1 minus 2 is going to give me x to the negative 1. When you simplify, you don't want negative exponents. So I'm just going to move them down. I just got to flip them down and take the reciprocal. So that's going to leave me with 1 over 2. I'm going to move the w to the 5th power down and x to the 1st power. We are now simplified. That is as low as it's going to go. Let's do one more checkpoint here. Let's do number 6. You see I have a power of a product, so when I distribute, I'm going to have 3 to the negative 2 times y to the negative 2 times power to a power. I have to multiply, so that becomes z to the negative 4. I can see, anytime you have any number, you're going to always put it over 1. But I can see every one of these are negative exponents. So I'm going to flip them. I'm going to take the reciprocal of all of those and make them positive. So that's going to become 1 over 3 squared times y squared times z to the 4th. We can simplify from there by saying 1 over, what is 3 squared? 9. So 9 y squared z to the fourth. That is now simplified as low as it's going to go. Okay, that is lesson 8.3. And on your assignment, we're doing all of them.